Okay, thank you. So I'm going to tell you today something about the ice conditions and how we utilize them in the design portal for offshore wind turbines. But first, something background, like why we are interested about these ice conditions is that there's a huge drive for renewable energy, for wind energy, and where you can find good places could be from the sea, so that the offshore wind farms could be a solution. There is a higher constant wind speed than on land areas, etc. So when you do an wind farm at the sea, in Finland you have to take into account the sea ice. And what happens when you have a wind turbine and then you have sea ice? If it's moving, it makes huge loads to the wind turbine, and the turbine starts to vibrate and stuff. And we want to make sure that the turbines are safe, so they don't break down at the first winter, or and otherwise that they are somehow cost effective. Of course, you could make really heavy structure, but that would be so expensive that nobody would actually build it. So for this reason, we've been doing this ice load portal for the Baltic Sea, where you can pick a location and you get information about the ice thickness and significant wave height, depth, etc. And based on these, you can get the environmental loads for your structure. Then you can go on and you can decide what kind of wind turbine you're planning to decide, how big and stuff like that. You can plug in your details of your turbine, of the substructure and tower and so. Then you decide what kind of load models you're planning to use. And then you just run the analysis. And you get the picture that does your design actually, can it withstand the environmental loads caused or from ice or waves or stuff. And if you're not happy, you can try a different location, different kind of design, run an analysis again, and check how it goes. So benefit of this thing is that it speeds up the early design phase because all this data and models, they are integrated into the same tool. So you don't have to pick your location, ask somebody about the environmental conditions, and then check out what could be a suitable design and do all this for every location you're planning. But you can just simply in this portal go and change all these things and see how it goes. And you also can use the information you get from the portal, you can use later on when you're doing your final design. So the ice condition data is in important part of the portal, because that's what affects the biggest loading to a turbine in the Baltic Sea, where there is sea ice. And we are using the ice condition data we are using is based on the Finnish Meteorological Institute's ice charts, which they have been producing over 100 years, and they have been used for winter navigation. So as you can see, there's this map on the right hand side where you can see like estimations about how thick ice somewhere has been on that particular day and what kind of ice types there have been and stuff like that. So within the Araya project, we've been doing this portal. The FMI has digitized their old ice charge from 1980 to 2006, so that we can use them to decide what kind of to decide the design parameters what we are using in the portal. So when you're actually doing a design, so you have to know some specific parameters of ice. Those are especially the 50-year maximum ice thickness, which means that the thickness of ice what's occurring once in 50 years. That's the starting point. Then you have to know like how many days of 20 centimeter thick ice you will have during the lifetime of the wind turbine. You have to know whether the ice is drifting or is it staying at the same spot, or if there's ice ridges or something like that. So you have to get the whole picture of what kind of ice environment there is. And we've been calculating this data, which is based on the historical ice charge, and we are including it now into this ice load design portal. And this is actually a unique database, so that in my knowledge there is no place in the world where they have done something like this, so that they have done for the whole sea area these design parameters. It's rather so that if you need to take the ice into account when you are planning an offshore wind farm, they just check out what kind of ice conditions there are at the site they are planning to do it, but no such a database exists. And so we are doing it for the Baltic Sea now. And as an example, you have at the right, there's the map of maximum degree of ridging at the site. So that's based from the ice charge that you can see that the more yellow it is, the heavier ridging it has been at some point at the history. So the heavier ridging, the heavier loads. So it's one of the parameters you can look and check out what you have to take into account. So, as a conclusion, so these historical ice charts are valuable information for us, and we are processing them now into design parameters. So from the daily charge to kind of statistical design parameters, and you could also use this data set in other applications as well. And I want to acknowledge my colleagues in FMI, Semantum and VTT, and also the funders. Thanks.